Alright guys, we got a video here on data representation and two-way tables. Now, we've talked about how to collect data. We've talked about several different sampling methods and, the pros and cons of many of them. But now we're going to talk about what we can do with that data after we collect it. But real quick, before we do that, I want to just do a little bit of review, little warm-up question here to kind of get your brains in the data mode. So, Mrs. Durangs wants to know how many middle schoolers prefer dogs to cats. She collects a sample by asking 10 random students from each grade, what method of sampling is this? So pause the video, think about this for a second. Maybe you don't have to pause it. What kind of sample method is this? Okay, hopefully you looked at this and said this is a stratified sample. So real quick, we can review a few of our sampling methods here. So our first one that we talked about was simple random, which is where you just literally randomly grab multiple subjects from the population to make up your sample. There's no real rhyme or reason to it. You just randomly select. That's the most basic form. Systematic sampling was the next one. That's where you have some sort of pattern. So say you sample every third person who walks past you or every third person who enters a school or something like that. Still random, but you just have some sort of system or pattern that you do. Stratified sampling is what this is. That's where you subdivide the population into subcategories or strata, so to speak, and then sample randomly from those categories. That's what this is, right? We're subdividing the population of middle schoolers into different grade levels. That would be considered stratified sampling. And then the last sampling method, last random sample method that we talked about was cluster sampling, where we divide this population into groups and we sample everyone in several random groups. An example of that would be if you walk into a school, pick 5 random classrooms, sample everybody in those classrooms. That would be an example of cluster sampling. Again, all 4 of these are random samples and generally give you a pretty good representation of the population. There were a couple non-random sampling methods that we talked about. Convenience sampling, where we sample individuals that are convenient or easy to access. This can introduce bias because of potential location, time of day, things like that. Really a lot of different things can introduce bias when it comes to convenience sampling. So you want to avoid that if you can. Also volunteer sampling or a self-selected sample. Want to avoid those as much as possible too, because typically when you ask for volunteers or ask a sample to self-select itself, typically you get a certain type of subject that would volunteer to take a survey or something like that, right? An example of this could be if you're looking at like Amazon reviews or something. Typically those people are either going to be very happy or very sad or very angry, right? They're going to have strong emotions one way or another. You're not going to get that sort of middle crowd there. So those two types can introduce a lot of bias: convenience sampling and volunteer or self-selected sampling. But this is a good sample. This is stratified sampling. We're really making sure that we've got an equal representation from each grade level by asking 10 random students from each grade. So this is stratified sampling. Okay, cool. So a little bit of review there. Let's move on. So now that we know how data is collected with these different sample methods, let's look at how it's analyzed and sort of what can we do with it afterwards. So the first thing we need to talk about is the 2 main types of data. We've got categorical data and quantitative data. Categorical data, with the root word category, is data that is not measured with numbers. Things like eye color, pet preference, as we just saw, hometown. Maybe you can think of a few other data categories that might not be measured with numbers. So anytime something is measured with like color or different animals or something like that, that would be considered categorical data. We could also call this qualitative data because you're measuring the quality of something rather than the quantity. And on the other side, we have quantitative data, which is data that is measured with numbers, root word quantity. right? Things like height, weight, or maybe points scored in a game if you're into sports, something like that. Maybe you can think of a few other examples of quantitative data as well. So two main types of data: categorical, quantitative data. We are going to focus primarily on categorical data for this video. So let's move on and get into that. So a little bit more vocabulary. Observation. This is the value of something of interest. Now I say value, that typically implies a number, but it doesn't have to be a number. It can be a categorical value, something like eye color or shirt color or something like that. But it can also be a number, a person's height or weight, for example. So it is the value of something of interest. And we would consider this an event in an experiment. So if we sample somebody and they have brown eyes, that would be an observation. Now a variable is the characteristic or quantity that we are measuring. So something like gender, height, weight, age, or hair color. Those are all variables, things that can change from subject to subject. So yeah, important vocabulary terms here. Make sure that you get these. All right, a two-way table is the main subject of this video. So two-way tables are a way that we can display categorical data in two variables. So these show up in the form of a grid-like table where you have one variable represented on the top with columns and one variable represented on the left side with rows. And I'll show you some examples of this in a minute here. And this allows us to measure, like I said, two variables at a time. So here's an example of what a two-way table might look like. So for example, the scenario where we were surveying pet preference in dogs or cats, well, we could also, if we were interested in whether boys prefer dogs or cats and how the preference differs with girls, we could also add gender as a variable here as well. So you can see we've got our first variable on the top here, dogs and cats. So our first variable on the top is pet preference. And then our second variable on the side here is gender. Now I just made up these numbers, but typically as we do a sample, as we observe the data, we can enter it into the table. So for example, there were 6 boys who were surveyed that preferred dogs to cats. There were 4 boys that were surveyed that preferred cats to dogs. And that means there were 10 total boys surveyed, right? 6 plus 4. And so you can see the different values for the different cells in this table. The last column and the last row are always the total columns, and then this last cell down here is the total number of observations that we made. So that is a two-way table. That's an example. So a little bit more vocab when it comes to specific terms related to two-way tables. The frequency, if you hear me talk about frequency, that refers to the number of times a particular outcome is observed. So for example, if we go back up here, the frequency of girls who like dogs was 3, right? The frequency of girls who like cats was 9. Okay, those are frequencies. The individual numbers are called frequencies. Now, relative frequency is very similar, but it is the number of times a particular outcome is observed out of the total number of observations, right? So all you have to do is put that number in the numerator and put the total number of observations in the denominator. It's a fraction, or you could convert it to a percentage, right? So frequency and relative frequency, got to know the difference there. Very similar, but slight difference. Okay, so like we said earlier, the frequency of boys who prefer dogs was 6. The relative frequency of boys who prefer dogs was 6 out of 22, or 6 over 22. And if you wanted to convert that to a percentage, you could do that. It is about 27%. 27% of boys preferred dogs. I'm sorry, 27% of people surveyed are boys who prefer dogs. There's a very important distinction there. So yeah, the relative frequency is the frequency over the total. Okay, so now it's your turn. I want you to pause the video and try to create your own two-way table using this information here. We're saying that there are 25 students surveyed. 11 of those students are boys. There are 7 boys who play sports, and there are 8 girls who do not play sports. So I'll start by giving you guys the variables, and then you can pause the video and try to make your own two-way table here. So our variables in this case are gender and whether or not that person plays sports. All right, pause the video, make a two-way table. Okay, hopefully you were able to figure this out and get your two-way table all organized. So we're going to end up with 4 columns and 4 rows here, and I'll show you what goes in each one as we start to fill this in. So our variables, like I said, go along the top and on the left side here. So it doesn't matter which one goes where. I'm going to put the whether they play sports or not on the top here. So I'm going to say plays sports or does not play sports. Okay, so that's my 2 variables, and then this last one here is just the total column. This top left one is always blank, so you can kind of just leave that. It doesn't matter. You don't need to put anything there. And then the left side column here is going to be the gender variable here. So we've got boys and we've got girls here. And then down here will be the total. Last row, last column is always the total. Okay, so let's start by filling in what we know and then use that information to fill in the missing cells here. So there are 25 students surveyed. So that is the total of the totals. So where the total column and the row intersect, that number is 25. This is the entire sample size is 25. There are 11 boys sampled. So that is the total of the boys. So where boys and total intersect, we can write 11. Now there are 7 boys who play sports. So there are boys and ones that play sports go right here. So that would be 7. And there are 8 girls who do not play sports. So in the girls row, where that intersects with does not play sports, we write 8. Now it looks like we've got a lot of missing information here, but we can actually solve every piece of this puzzle just with the information that we have here. So I'm going to pull up a calculator just so I don't get anything wrong. So if we have 25 students total and there are 11 boys, well, that means that the number of girls is 25 minus 11. So there are 14 girls. 14. Okay, cool. So we got that one. So so next we can look at this boys row here. So if there are 11 total boys and 7 play sports, that means that 4 of them do not play sports. Okay, those are the only 2 options here. Likewise, if 8 girls don't play sports and there are 14 girls total, well, that means that 6 girls play sports, right? And then you can see where I'm going here. We can simply add the total of boys and girls to get the total number of students that play sports, which 7 plus 6 is 13. And then 4 plus 8 is 12. And then we can confirm by adding 13 and 12, and that does actually equal 25. So here's what your two-way table should have looked like with the information given. Hopefully you got that right. Okay, so the last thing I want to show here, we'll wrap this up pretty quick here, but the last thing I want to show here is that two-way tables, although they show 2 variables, there can be more than 2 outcomes for those variables. So for example, let's look at eye color. So if I were to make a two-way table of, let's say, middle school grade level and eye color. So those are my variables here. Variables are going to be middle school grade level and eye color. Well, obviously there are more than 2 eye colors, and there are more than 2 middle school grade levels. At least at our school there are. So if we make a two-way table with this, it might look something like this. We're going to have more columns and more rows last time because we have more possible outcomes here. But like I said, this first upper left one is always going to be blank. You can shade that in if you want to. But I'm going to let's put eye color on the top here. So let's say, just throw a few of them out there. Let's say brown, blue, and green. I know there are probably more that we could think of, but we're just going to roll with 3 for now. And then again, we have total on the very end. And then middle school grade level, we can say 6th, 7th, and 8th. And then this would be the total column down here. So this is what the two-way table might look like for for variables that have more than 2 outcomes, right? So these tables could get as big as you can imagine, right? But they only ever show 2 variables, right? One with the rows and one with the columns. Now I don't have numbers for this, but you can use your imagination to fill them in, or you could do your own survey and see what you come up with. But yeah, that is two-way tables. Reach out to me if you have any questions about this. I'd be happy to help you out.